Good afternoon, everyone. I'll wait a little longer, like usual. And yes, Isaac, I'll go over the question you asked. Yeah, well, it's 1:06, so we can go ahead and begin. Okay, a few things to go ahead and go over. If you're not already aware, cap and gown pickup is next Friday. Cap and gown pickup is next Friday. It's between 10 and 1 based on the last names. This is just from the Langham Twitter page. It's posted many places by now, so make sure you pick up your cap and gown, as well as the Senior Sunset Recognition event next Thursday, 7 to 9. Should be fun, I guess. You should come. I'll be there. Lots of teachers will be there. Just want to make sure that you're aware of those two things. This right here is all the same information I've been saying every time. Your exam is Tuesday at 1. You need to log in at 12:30 with the information you'll be given on Sunday. This is all of the links that I posted on Tuesday that will be helpful to knowing how the online system works and what is expected of that system and what you can and cannot do and what you can and cannot upload and those kind of things. So if you haven't already checked all that information out, you definitely need to for the exams. Before I start answering any of your questions about calculus and preparing, does anyone have any questions about the AP exam process? Does anyone have any questions about the AP exams and the process for how and what you can upload and what you can do and any of that? Okay, then, well, I'll go ahead and start answering some of your calculus questions. Earlier in the AB lesson, they were confused about when and to know to use intermediate value theorem and mean value theorem, so I went over that in depth with them. So if you're wondering that as well, you could watch the AB video at some point. But Isaac asked about in the BC practice problems number 3, the BC practice problems number 3, and specifically part C. This is the one you were asking, right, Isaac?
Yeah.
Okay. Okay, so we are told that g of y is 20/3 times c minus y, where c is a positive integer. We are asked to use partial fraction to integration to find the expression for y of t. Well, if we were to plug this g of y into the g of y spot, we then get, and there we go. We then get dy dt equals 3/20 y times 20/3 times c minus y. Okay, the 3/20 and the 20/3, those would end up canceling, and we would just be left with dy dt equals y times c minus y. Which does look like a logistic differential equation. That does look like a logistic differential equation, and in a logistic differential equation like this, what does this C represent?
Carrying capacity.
Yeah, that's the carrying capacity. That C is the carrying capacity. We usually called it M. Here on the graph, it's also called a capital L. So we can see here that C is then that C is the L from the picture. Okay, and we are trying to figure out what the y function is, and we're going to use separation of variables to do that. And when we integrate, we're going to have to, as they told us, use partial fraction integration to figure out what that is. Okay, so first we're going to move everything on the right over the left and move the dt over to the right. And I'm going to write that up here. So that gives us 1 over y times c minus y, that's the y, dy equals, technically there's nothing on the right side, but we don't want to think of it as like nothing like 0. dt got multiplied over to the right side. I'm going to put it as 1 dt. I'm going to integrate both sides. But the problem is this left side now needs partial fraction decomposition. So before we can integrate that, we need to separate it into something over y plus something over c minus y. Okay, using the same method that we learned, let's take the first one. What's going to make y 0? What's going to make y 0 is, well, 0. So now we'll go back to the original thing and plug 0 in for y. And if we, well, we're covering up the y. We cover up the y and plug 0 into the other y, we get just 1 over c. So that gives us 1 over c there. And doing the same thing with the other one. We want to know what's going to make this c minus y equal to 0. Well, the thing that's going to make c minus y equal to 0 is when y equals c. It's when y equals c. So if we then cover up that parentheses, the thing above, and plug c in for y, we get 1 over c. Well, 1 over c is just a number. So let's just go ahead and factor out the whole thing. And so we have 1 over c, integral of 1 over y plus 1 over c minus y equals integral of 1 dt. Okay, now let's integrate. Well, what's the integral of 1 over y?
Natural log of absolute value of y.
Yeah. And while we're right here, are we all good on what I've done so far? Any questions on what I've done so far? Okay. When we integrate 1 with respect to t, that'll just give us t, but then we would normally put plus c, but we got some c's already here. So instead of using c, let's just use some other random variable. What random variable do we want?
B.
Oh, we can use b if you want b. Okay, so b. B's fine.
With the c minus y term, do we not need to bring out a negative with any chain rule, or is it just the bottom without any multiplications?
Sorry, yep, you're right. You're right. We did need to. So there should be a negative in front of that natural log. That should be negative natural log of c minus y. Yeah. Yep, I made a small mistake there. Costly one. No. Okay, well, now to continue on. We want to get all the way to what the function y is. So we're going to need to plug some stuff in. Well, do we know any points? Do we have any sort of initial condition that we know about this function? We know that when x is 30, y is L over 2. And I already did say that L is essentially C here. So when x is 30, y is C over 2. So we're going to plug that in now. We're gonna plug that in now. So that's going to give us 1 over C, natural log of C over 2. Which would already be positive. I mean, we know the y value is positive there, so I don't really need the actual value sign anymore. Minus, go ahead and just, I'll have that parentheses there. Minus natural log of c minus c over 2 equal to, well, it's at time 30 plus this constant b. Well, c minus c over 2, that is just c over 2. And we have natural log of c over 2 minus natural log of c over 2. Because we've got this minus sign in the middle, we can combine them and dividing the insides, which would become natural log of c over 2 divided by c over 2. But what is c over 2 divided by c over 2?
1.
It is just 1. C over 2 divided by c over 2 is just 1. And so this is just natural log of 1. And then what is natural log of 1?
0.
0. So we have 0 times 1 over c equal to 30 plus b. Okay, so then b, I'll write it up here, b must equal what?
Negative 30.
Negative 30. Okay, that's helpful. Now, we're going to go back to this line here, plug negative 30 into b, and then just solve for y now. Okay, I'll also go ahead and combine this section over here. That gives us 1 over c natural log of y over c minus y equals t minus 30. Okay, now we're just solving for y. We'll now multiply both sides by c. And then we're going to e everything. So then that will give us y over c minus y equal to e to the c t minus 30, like that. Okay, on that left side, what could we do with that?
Multiplies c minus y.
Yeah. Okay.
We'd have to like split that fraction somehow,
Well,
right?
we can't as it's currently written. If the subtraction was on the top, we could split it, but the subtraction's on the bottom. One second, don't want to show it wrong, so I'm gonna check what they did. Okay, they got all the way to there as well. That's what we just wrote. Okay, yeah, just continue solving as Isaac suggested. Multiply by c minus y. When we multiply by c minus y, we'll then get y equals C e to the C t minus C 30 minus y e to the C t minus C 30. And now this term that has the y, we're going to add it to the other side and factor out y. Then y will be by itself. If we add that to the other side, we'll have y plus y e to the C t minus C 30. No. So this term right here on the far right, we're just adding it to the other side. So y plus y e to the ct minus C 30 equals C e to the C t minus C 30. Factor y out on the left, and we have 1 plus e to the C t minus C 30. And then just one last step. Y is then C e to the C t minus C 30 all over 1 plus C e to the C t minus C 30. And it should be what they got. Yep, it is. Does that help, Isaac?
Yeah, but why they also had like another answer with that? Is that because it's still considering the absolute value, or do we only need this one because we can already see the logistic curve is positive or not reversed?
Okay, so well, so we already said that C is L, which is the carrying capacity. So this whole section here, which is also the answer we got, I would say that's the more correct answer. That would be the one, if you were ever asked to do this, would be the one you're expected to find, especially because what they have right here says y is between 0 and L. Y is between 0 and C, between 0 and the carrying capacity, meaning this y function here represents the function that's drawn for us. That is the blue function that's drawn for us. Well, the other that they do down here, this says y is greater than C, meaning greater than the limit carrying capacity. So this y function down here that they have, which the only difference is that negative right there. No, that is the only difference. Oh, that negative right there and that negative right there. So these two things are both negative, is the difference. That is if you knew you had some initial condition giving your function way up here, above the carrying capacity. Because that section that they did said that y was greater than L, or y was greater than C. So I wouldn't expect you to do that section, or they wouldn't as well, if you know that you have an initial condition that's over here. We had an initial condition that when x is 30, y is L over 2. Well, if that's our initial condition, then the y value is stuck between 0 and L. And so the equation we got was the correct one, based on the initial condition.
Okay.
Okay, yeah. Any other questions about any particular concept or any particular question or assignment?
So a lot of these FRQs had like graphs and tables and stuff, but like I didn't see a lot of like related rates or optimization stuff. Do you think that stuff's gonna be on the AP test still, or is it like it's gonna be graphs and tables? Like stuff we see.
Well, having graphs and tables, they could still ask a related rates question or could still ask an optimization question. That is possible.
Yeah. Just haven't really seen it in these FRQs.
But no, not very few of these ones had any of that. With both related rates and optimization problems, if you have those kind of questions, just go into it knowing the steps of those problems. I don't see you having an optimization question that is crazy difficult.
Yeah.
I think it's higher likely that the two free response questions would be mini parts so that the whole thing will take up the entire amount of time you're given, than that any particular question would be crazy difficult, especially if it's an AB material. And so if you have a related rates question or an optimization question, it's probably going to be like one we have seen in class. But while I didn't have it in any of these, the guys who are doing the AP Live YouTube videos, they when they covered Unit 5, well, and Unit 4, when they covered Units 4 and 5, they probably went over some types of free response questions that would still have related rates or optimization. But just go into it knowing the steps. I don't anticipate those kind of questions being super hard. It's probably going to be similar to ones you've seen in that I've given you.
Yeah.
Not the crazy ones, though, of those two types of problems. Any other questions?
I know that you recommended for us doing the circuit before the test, but that's the grade that's technically for the next week, the next week that with the AP tests.
Yeah, it's technically for next week. That's just because based on district guidelines for the last 6 weeks of school, we were supposed to have one grade per week. And so for the grade for week of May 11, I didn't want to have much work. I was originally planning on putting the circuit this week and had at first no idea what I was going to assign for next week. Then I thought that I could just give it out super early and then say it was next week's grade. So it is next week's grade. You could do it ahead of time for preparation, or you could do it after the exam. It really doesn't matter when you do it. Although with that being said, make sure you do realize, I said it in the Google Classroom yesterday, now that graduation is moved up to June 1st, Monday, June 1st at 8 a.m. outside at the Berry Center. If you haven't known that yet, that's when graduation now is. Because of that, all senior grades are due the morning of Thursday, May 21st. All senior grades are due Thursday, May 21st in the morning, which is why I also changed the due date for the last week of school, that Google form. I changed that due date to the 20th so that I would have it in time. And that particular Google form is just 4 calculus questions, and the rest of the questions are just questions I was curious about. How you think you did on the exam? Where are you going next year? What'd you enjoy about this year? Those kind of questions. So 4 calculus questions, then a bunch of those kind of questions. That's all that Google form is, which is the last grade of the year. And if you're one of the small few people who have not done any work or very little work, you need to turn something in. For the first 2 grades, I was very lenient, just looking for, did you do the majority of the assignment for the first 2 weeks? The last week and this week, I'm actually going to grade it based on the key. And then the next 2 are also should be super easy. The key for the circuit's already posted as well. Any other questions?
Yeah, I have a question about the BC1C part.
For which one?
The BC1,
In the practice questions or on the mock exam?
the mock exam.
Okay. Mock exam,
Part
BC1.
C, the meaning of the equation.
Which part?
C.
C? Okay, let's share screen. So part C asks you to come up with a left Riemann sum with 3 subintervals based on the data in the table to approximate 1/45 times the integral from 0 to 45 of W of t. Okay, well, ideally we recognize that 1/45, well, that is 1 over b minus a, with 45 being b, 0 being a, times the integral from a to b of a function. Well, if you take the integral of a function and divide by its width, that is the average value of the function. That is the average value, f AVG for average. That's the average value of the function. So this integral here, 1/45 times the integral, that gives the average value of W of t over that time period. The average value of W of t over that time period. And W of t, they said, was y, which they also said was the workers at the office at a particular time. The workers at the office at a particular time. So W represents the number of workers in the office. W is the number of workers in the office. Then this integral, the meaning of it represents the average. That's not how you spell average. A-V-E-R-A-G-E, whatever. Average value of number of workers in office from 0 minutes. Whoa, what just happened? Why did it do that? Go back to where it was. From 0 minutes to 45 minutes. And they also want you to use correct units. So if this is representing the average number of workers in the office, then this answer should end up being in number of people in the office or number of workers in the office. Oh, that's what they said. Oops. Yeah, they have the units and workers. Units and workers. Then it is the average number of workers between that time period. Because anytime you see something like this, or if you're asked to find the average value of something, that the average value of a function is the integral from the beginning to end divided by the width of that interval. So 1 over b minus a times integral from a to b of the function. Now, does that answer your question, Logan?
Yeah.
Okay. Any other questions from the mock exam or the practice questions? Oh, Jessica left. Well, y'all have no other questions. Would y'all want to play a Kahoot?
Sure.
Okay. You will probably need 2 devices, the computer to see my screen to see the questions, and then your phone to do the answers. Nine oh nine 0824. Is that everyone? I feel like we're missing somebody. Do I need to continue to wait, or can we start?
I'm ready.
Okay, we're gonna start. I need to move this though. Oh, I need to make it smaller. Good. Yeah, I don't get how you got 3. If you got 3. In limit problems, you should always first try to direct substitute. If you direct substitute 2 in there, you get 11 over 0. If you have a number divided by 0, that is undefined and does not exist. Oh, one of these question answers is super tricky. And if you said yellow, you were taking the derivative, but then still had C. This is a good question for this. Yeah, it's taking all this long. You're thinking too hard. Good. On a free response question, if you have something nasty like that, but still equals a number, don't try to simplify. Don't try to simplify. Cosine of pi over 3 is just a number. E is a number. So e to all that times that, that's a number. Don't try to simplify that. If that's your final answer, then just leave it and go on to the next part of the question. Green would be asking for a derivative. Knowing an amount and wanting its rate of change, that you'd be doing a derivative. Well, yellow, if you know a rate and you want its change in the amount, that would be the integral. Wow. Those of you who chose yellow, you would be right if it asked which of the following would make y equals k an asymptote. Because if you take the limit as x approaches infinity, and that equals k, well then that k is then a horizontal asymptote. K is then a horizontal asymptote. Well, they're asking about x equals k, which is a vertical line being an asymptote. For x equals k, which is a vertical line to be an asymptote, then as we approach that x equals k, it should not exist and should be going towards infinity. Okay. Go back and look at the picture. The absolute max would either occur at the endpoints or where a maximum would be. Well, if this is a graph of f prime, then the max, a relative max, would occur when the derivative changes from positive to negative. So right here, when x is 3. When x is 3. And that's probably why some of you chose 3, because that's where the max does occur. But it doesn't ask at what x value does the absolute max occur. It asks what is that absolute maximum value. That absolute maximum value we would figure out by using fundamental theorem of calculus. That they told us f at the beginning, they told us f of 0. If we add f of 0 to the accumulated area, we could get f of 3. Well, the area under the graph from 0 to 3, well, that's 2 times 2 divided by 2, which is, no, not divided by 2, that's just 2 times 2, which is 4. This triangle is an area of 1. So this whole area has an area of 5. Well, it started off at -1, added an area of 5. So when x is 3, it's 4. Wow, we all got that wrong. Oh, yes. So I chose right Riemann sum because I was visualizing it increasing and concave up, which would cause an overestimate. But if it was decreasing and concave up, that would actually be an underestimate. Midpoint and left, for the same reasonings, we don't currently have enough information to know whether it just being concave up would be an overestimate or underestimate. While a trapezoid Riemann sum, since it connects points and it's concave up, all of those line segments connecting the points would end up being above the curve. So that was dumb on all our parts. Whoever's Brian Passwater, have you actually been watching his videos?
I watched some of them.
Good. Red, which is the correct answer to their question, is actually the conclusion of Rolle's theorem. F having a local extrema and that there being a horizontal tangent somewhere in the interval, that's the conclusion to Rolle's theorem. Well, all three of the other choices are conditions to Rolle's theorem. Okay, well, glad no one chose green. Why is blue not right? Why is blue not right?
No absolute
Doesn't-
value.
Yeah, they don't have the absolute value. The integral of 1 over x dx is the natural log of the absolute value of x. Natural log of the absolute value of x. Zeus, now that you're with us, we already finished answering questions that people had. We're just doing a Kahoot now. You could join, the pin's at the bottom. Yellow doesn't give distance. Yellow would end up giving some future value, like the distance plus the beginning movement. The ending, it would more give the ending position. The ending position. Well, just integral of the absolute value of velocity is distance. Integral of absolute value of velocity is distance.
Could particle motion be on the test, or is that unit 9?
Unit 9 was parametric vector polar. The question we just now did was particle motion, but that was unit 8. when we did that concept of distance and displacement. That was in Unit 8. We did that back in before spring break. Well, the same unit. Actually, we did that particular question the first week of the spring semester. That concept, distance and displacement and future value. We did that first week of this semester. So yeah,
Alright.
Unit 9's not on the exam, but Unit 9's parametric equations. That was thinking of velocity as just one rectangular velocity equation, because it did specify of just dealing on the horizontal x-axis from x between A and B. Square root of x squared is just the absolute value of x. Okay, we clearly need to talk about this. Concavity, yes, is when the second, it being concave up, yes would be when the second derivative is positive. It would be when the second derivative is positive. But let me do something real quick so I can write on that. But the thing we want to know whether it's concave up or not is g. We want to know if g is concave up or not. Meaning we need to know about the second derivative of g. Well, first derivative of g, well, using second fundamental theorem of calculus, first derivative of g, since g is a accumulation function or area function, would just be f of x. Therefore, nope, I wanted to write g there. Therefore, second derivative of g would be f prime of x. So if we want to know when g is concave up, that means we need to know when g double prime is positive. Well, g double prime is f prime. So we need to know when f prime is positive, which is choice green. But f prime being positive is also, just by definition, when f is increasing, which is why blue is also correct. I would be willing to guarantee you that this concept will be on the exam. An integral function will be somewhere on the exam. They will define an integral function for you. You'll have to deal with its derivative. There will be function analysis involved in an integral function question. I guarantee you. I would be shocked if that was not on there. Okay, you're given f prime. Where would f have a local minimum? Where would f have a local minimum if you know about f prime? So both choice, really all of red, green, and yellow are describing if you were given the function f. If you had the function f in front of you, its graph, that's how you would tell where the local minimum is. But blue is for the situation we're dealing with, where you have the graph of f prime in front of you. If you have the graph of f prime in front of you, then the y values on the graph in front of you represent the y values of f prime, and when f prime changes from negative to positive, that's where you have a minimum. Red, blue, and yellow are all equivalent statements. Red, blue, and yellow are all equivalent statements. If you have a point of inflection, based on the definition of point of inflection that we dealt with every time, that would mean that f double prime does change signs, but the second derivative changes signs because it would change the concavity. But if your second derivative is changing signs, then that would inherently mean that the first derivative has a critical point there and would have a local extrema there, would have a local max or min. Because a local max or min occurs when the derivative of it changes sign. So then f prime has a local max or min when f double prime changes sign. So again, red, blue, and yellow are all equivalent statements. The reason green is the answer here, and that it does not necessarily have to be true, is that something can be a critical point if either the derivative is 0 or undefined. So f double prime of 1 doesn't absolutely have to be 0. F double prime of 1 could be undefined. Okay, U-substitution. U-substitution. And as another reminder that I've said this many times, if you have an integral question on the test, try U-sub first before you try integration by parts. Try basic U-sub first before you try integration by parts. And for questions like this, it's helpful to think of U-substitution as just reversing chain rule. Meaning, since chain rule multiplies by the derivative of the inside function, when we do U-sub, which is reverse chain rule, we need to divide by the derivative of the inside function. Well, the derivative of the inside function here is 2, so we need to divide by 2 somewhere to reverse chain rule. And that's where we get the 1/2, which everyone noted that, so that's good. But green is the more correct answer, so that we can replace our limits. We'll just go 3 more minutes to 2:10, and then we'll be done, whatever question we're on then. FT represents the rate at which something's price changes. Okay, so F is a rate here. F is a rate. Keep that in mind. F is the rate at which the price is changing. When is the price increasing? Okay, good. Glad most of you got that. So the price would be increasing when the rate at which it changes is positive. When the rate at which it changes is positive, because a function in general is increasing when its derivative is positive. So the price is increasing when the rate of change of the price is positive. Well, the rate of change of the price is a volume question. Region whose base is not flush with the line it's revolving around. Okay. Meaning it's not touching the line it's revolving around. So this is really just asking for the washer method formula. Just the washer method formula. Because disk method, it's touching the line it's revolving. F is twice differentiable at x equals 3, which of the following may not be continuous. So it does say may, meaning just it doesn't have to be continuous at x equals 3. Good. Yeah, it just says it's twice differentiable, so that doesn't tell us anything about the third derivative. Ooh, we did this so many times. We did this so many times. Ideally, it was memorized. A lot of people in AP have memorized, but I don't remember. Good. No, we'll just do one more. 24 questions. Okay. When you have a tangent line approximation of f at x equals a, when is it an overestimation? When's it an overestimation? Okay. Blue is right because when you are concave down, so think of a U and a tangent line approximation, you're putting a line tangent to, not a U, kind of an N, I guess. Frown, remember? Concave down makes frown. So you're concave down and you put a tangent line on that. That tangent line would be above the curve, no matter where it is when it's concave down. But if you're concave up, a tangent line would be below the curve that whole time. Okay. Well, I won, but whoever's Leibniz did really awesome. Good job, Leibniz. And really all of you. Thank you for joining. Thank you for continuing to try. Good luck on the AP exam. Prepare as much as possible. Be rested. Yeah, I mean, second place is great. I had first, so I mean, you got first out of all the students, so that's good. I probably wouldn't have played if we were actually at school. And I did want to do this. We would have done this Kahoot if we were actually at school. The Friday before the AP exam, we would have done this Kahoot. So, well, glad we still had to have some semblance of normalcy. But again, have a good weekend. Prepare, but also be rested. Have a good break. Have a good weekend. Come to the Senior Sunset next Thursday. I'm not sure if we'll meet next week or not. I don't want to inhibit any of your AP exams because I currently don't know the best time sometime next week to have class because of the AP exams. We will for sure meet the following week because there's almost no senior exams that week. The Wednesday of that following week is just AP English 3 language and comp. So we'll meet that day. I don't know if we'll meet next week or not yet. But you should come to the Senior Sunset next Thursday. I can see you then.
Would you announce on the Remind over the weekend if we were having class or not?
If we do have class, I'll probably combine it with AB. Maybe it's not like a survey of like when would be a best time for everyone to meet.
Okay.
And then people can just bombard me with remind messages. Okay. Well, yeah. So I just don't know when would be the best time to meet next week because of lots of people are in all sorts of AP classes, and I don't want to inhibit your exam or your studying time. Okay. Well, if we do have class next week, obviously I would tell you ahead of time, especially since it would most likely be different than usual when it will be. Well, have a good weekend and a good day.
Bye,
All right.
planners.
Bye.